Hello YouTube, RJ. Today I've got a little experiment set up on the bench. I got to thinking, my linear power supply that I use quite often on the bench is an old Instatek GPC 3020. It's an old beast. I bought it off of eBay, I don't know, 10 years ago, maybe. It was old when I bought it. I think I paid $60 for it. I didn't give very much. It weighs a ton. Of course, it's an old linear with a big transformer, big capacitors. I got to thinking about it. That thing's this those capacitors have got to be getting tired in there. I just wondered how noisy it was getting. I always consider it to be my quiet power supply. I've got the little O1 SPE 6103 over here, but it's a switch mode power supply. It's got more current than the big linear, but it's electrically noisier. Generates a lot of harmonics and stuff. But I got to wonder how quiet that really was. And I've got the perfect instrument now that I've got the HP 3400A. So I rigged up a little experiment here, and to see just how it's doing, I pulled the specs here on it. And if you go down to ripple and noise, they're saying under 2 millivolts RMS. Well, we got the perfect RMS meter to check that right here. So I thought I'd rig it up and give it a test, and we'd see what we come up with. And in the process, I'm going to show you a little something else. So that's for my linear. This is it right here. I know you don't get to see it very often on camera, but so let's do a little testing on it. Of course, to test a power supply, you got to load it some, because obviously under no load, it doesn't take a lot of capacitance to filter ripple. So I've got the little load device over here set up for an 1.5 amp current. This is good for 2 amps per channel. So let's go ahead and load this thing up, and then we'll see where we are here. So let me get it loaded. We're pulling an 1.5 amp on it. So this is warmed up good. Power's coming in, going to the load, and being monitored here. So let's go ahead and start moving down. There's 1/10 of a volt. There is 30 millivolts. I don't think we're going to get lower than that. We're going to peg out, because if you look at the 3 scale, we're already about 15. So that's going to be 15 millivolts. So that's not even close to less than 2 millivolts. So we're not in spec. And I would say, well, I don't expect it to meet the specs as old as it is. The capacitors, obviously are not going to be as good as they were. But I would have expected it to be a lot closer than that. So let me show you a little something. Often you hear me say, let me turn my LED lights off because they'll generate electrical noise. And I'll turn them off, and maybe the video will be a little noisier because the lighting's not so good. Here's the reason I do that. Watch the meter. I'm going to turn the overhead lights off. Yeah, they generate noise. And that's okay. They work really well. I love how they light the bench when I'm working and such. But when I'm doing measurements, sometimes I have to turn those off. I remember and kill those because they do generate a lot of noise. You can see how much we dropped down. In fact, we've dropped down enough now. I think we can go to the 10 millivolt scale. All right. And let's see where we're settling in. We're settling in about 8.5 millivolts. Not too bad for a probably 30-year-old power supply. What this tells me is probably it needs the caps changed out in it, and maybe that'll be a project we'll do one day. Right now, that's still good enough, but one day we'll pull that beast down, tear it apart, figure out what it needs for caps, and order some caps and replace them. And I got a feeling we can bring that right on down. Well, there's that. But now the next question that leads to is, what does this thing look like? Be interested to see how it comes out on the ripple. So let's do this. Let's go ahead and back our meter back up. And before I do, let me kill this. And let me do this. I want to undo the connector, and I want to show you that when I go down to 10 millivolts, the needle does 0. There's no hocus pocus there. It gets down to 0. This meter's working great. No problems. So anyway, as always, we want to go up in voltage before we do anything. We're going to let this fan shut off. And I'm going to stop the video while I rewire this real quick instead of wasting your time. Okay, I'm back. Really straightforward. Everything is exactly as it was. I just pulled the banana jacks out of the linear, brought them down, plugged them into the SPE 6103. Don't worry about the bruise if you see it. The vampires, had to go get my checkup, had blood drawn, and the vampires got at me. They didn't do too good this time. So we're powered up. I'm set up for 10 volts, just like the linear was. I'm set up for 1.5 amp draw here, just exact same test. We've got it turned up to 1 volt to make sure we're not pegging things out and stuff real bad. I'm going to go ahead and turn the supply on and go ahead and load it. Okay, so we're pulling 1.5 amps. Everything agrees. Let's start going down and see where we get. Ooh, 0.1 volt. Okay, so on the 0.1, and I can't get over in front of the camera real well, so I'm a little parallax, but I'm going to say that's about 0.475, let's say. So that's going to be that's going to be 100, it's going to be 47.5. No, it's not. It's going to be, yeah, it's going to be 47 millivolts, right? Almost half of 100 millivolts. So we're on a 100 millivolt scale. We're almost half scale. So that means we're almost 50 millivolts. We're about 47.5 millivolts RMS. So quite a bit noisier. Turn the load off. Notice that it quiets down. Without a load on it, it's easier to filter. Load her back up. Go right back. Now, turn the lights on. Jumped up. You said, well, it didn't jump up very much, RJ. Well, proportionally it did. Remember, we're on a much higher, what are we on? We're on 10 times scale. So moving this much on a scale, if you multiply that by 10, remember it moved almost full scale on that 10 millivolt scale. So yeah, it's generating the same amount of noise. It's just not moving the needle as much on a higher range. So there you go. We're talking, what are we talking? 5 times the noise ripple coming out of this than the old linear, and the linear is noisier than it should be. So that's just part of the picture. Remember, there's a whole lot of switching noise and stuff going on in this thing over here, but not bad at all for the little inexpensive power supply. I'm impressed. So let's turn the load off. Let's turn this off. And that's going to be it for this video. That's all I really want to do. I want to do a little experiment on the bench here, look and see how my power supplies are doing, play around with my 3400A to be able to do that. It's nice to have an instrument designed to do that. So hope you enjoyed it. Hope you learned a little something. And most of all, hope to see you in the next video.